Nur Shahada, and I will explain briefly about efficiency and its general expression. So, efficiency is the percentage of the output performances that depends on the percent of the work that put in by the input or a user, plus the output work need to always lesser than input worker. Therefore, the percentage of efficiency always less than 100%. And that is why efficiency can be expressed in percentage as output power divided by the input power.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Aimanti Azman and I'll be presenting guidelines and requirements of energy efficient motor. The International Electrotechnical Commission interprets energy efficiency as the ratio between output performance compared with the input of energy. Economic growth indicates high energy demand. However, this energy demand can have negative effect on the environment. Thereby, energy efficiency is a cost-effective means for supporting the growing energy demand. As we know, energy efficient technologies are already available, yet some obstacles hinder the implementation of energy efficiency solutions. For example, one of the obstacles is that they focus on the performance of the device rather than the system. However, standardization can offer solutions to help defeat these obstacles. So, Advisory Committee on Energy Efficiency has developed Guide 118 and Guide 119. Guide 118 seeks to harmonize the energy standardization and raise awareness that IEC publications can affect energy performance in both positive and negative ways. It also assists the committees to distinguish energy efficiency aspects that contribute to the energy efficiency improvement of the product when developing standards. Meanwhile, Guide 119 defines the technical and organizational methods to follow for the preparation of these standards. It provides an overview of how a systematic approach can be adopted and defines the type of publication based on the assigned energy efficiency function. IEC also developed an international efficiency classification. The classification distinguishes between 4 efficiency levels, with the IE4 for the highest efficient motors and IE1 for the least efficient motors. The IE4 motors lies in the super premium efficiency range, with an output power from 2.2 kW to 230 kW, and speed range between 750 rpm to 3600 rpm. Next, the IE3 motors lie in the premium efficiency range, with a speed range between 750 rpm to 3600 rpm. The IE2 motors lie in the high efficiency range with a speed range from 1000 rpm to 3600 rpm. Lastly, the IE1 motors lie in the standard efficiency range with a speed range of 500 rpm to 3600 rpm. For the IE3, IE2 and IE1, this tree has a rated output power of 0.75 kW to 375 kW. Plus, for all of the efficiency level, the RPM frequency must be 50 Hz and 60 Hz only.
Next, we will continue on method on how to measure efficiency on low voltage induction machine. First of all, low voltage induction machine also can be defined as a squirrel cage motors with 3-phase power supply with a range of 200 volt to 690 volt and cover its spectrum from 0.06 kilowatt to 1250 kilowatts. To conclude the definition of low voltage induction machine, it is actually a low voltage motor with 3-phase powers that operate at average voltage that less than 1000 and it's produce their maximum powers up to 1250 kilowatt. According to the standards, there are 2 major ways to determine efficiency of low voltage induction machine, which is direct method and indirect method. For the direct method, the efficiency can be determined from the direct measurement of the input electric power and its output mechanical power. Meanwhile, efficiency from the indirect method can be determined by the input and output power measured used to determine the constituent components losses in the motor. Losses process is known as the summation of the losses. So, that is the 2 ways to calculate the efficiency for the low voltage induction machine.
Hi, my name is Amir Iskandar bin Muhammad Khalil and I will talk about methods to improve the efficiency of electrical motor. First is regular inspections. The most common cause of motor failure is low resistance. This occurs when the insulation of the windings is degraded by adverse conditions such as overheating, corrosion or physical damage, leading to insufficient isolation between windings, leakage, short circuits and eventually motor failure. Second one is protect against electrical overload. Electrical overload or overcurrent occurs when the current that the motor is designed to carry efficiently and safely is exceeded. The most common cause of this is a low voltage supply, which causes the motor to draw in extra current in an attempt to maintain torque. However, it can also be caused by short circuit conductors or an excessive voltage supply. The installation of effective overcurrent protection can detect overcurrent before it becomes a problem. Interrupting supply and protecting against overload, this will enable the motor to operate at maximum efficiency whilst reducing the chance of breakdown. The third is keep cool. With around 55% of insulation motor failures caused by overheating, the benefits of keeping your motor cool are clear to see. For every 10 degrees Celsius that the temperature of a motor is rise, the insulation life is reduced by 50%. The fourth is monitor vibration. Vibration in electric motor is commonly caused by an uneven or unstable surface. However, it can also be a result of an underlying problem such as loose bearing, corrosion, or misalignment. It's important to monitor vibration levels as exceed vibration can cause the motor to fail prematurely. And the last one is protect against contamination. Electric motors often operate in environments which are contaminated by dust, dirt, or chemicals. However, with contamination by one of the leading causes of motor failure, it is critical to ensure that electric motors are well protected against contamination.
Hello, my name is Atika and I'm going to continue the presentation with a little explanation on cost saving and payback periods of an energy efficiency motor. We know that an energy efficiency motor is basically an improved version of electrical motor which has better working performance. This factor contribute to cost saving as usage of energy efficiency motor can actually cost less than usage of standard motor. An energy efficiency motor have higher service factor, longer insulation and bearing lives, lower losses, less vibration which increase the motor reliability. We have to know that the amount of money can be saved by using an energy efficiency motor instead of standard motor depends on few elements like motor size, annual hour of usage, load factor, efficiency improvement, utility charges for electrical demand and energy consumed. There are 3 steps to determine the annual energy and cost saving of an energy efficiency motor. The first one is by obtaining a copy of utility rate schedule from the industry. Next is determining load factor and total of operating hour of the motor. And lastly is to calculate the annual energy saving by referring to the utility rebate provided by the industry. Payback period is a calculation that identifies whether the motor can be exchanged to more efficient motor at a monetary gain. The difference between a targeted efficiency and operating efficiency can be described as wasted energy points.
Hello, my name is Muhammad Zuhairi bin Mazaki and I will continue with calculation the cost saving and payback periods by using energy efficient motor. Now let's read the example above. Following analysis for 100 HP TFC motor operating at 80% of full rate load illustrate how to determine the cost effectiveness of obtaining an energy efficient versus a standard efficiency motor for the initial purchase case. Okay, so the main point we get is 100 HP TFC is totally enclosed fan cool motor and 80% of full rate load to get the kilowatt saved. Use formula kilowatt saved equal to HP multiply load multiply 0.746 multiply 100 per ESTD minus 100 per EHE. Okay, so HP is 100, load is 0.8. ESTD is standard efficiency motor, while value of EHE is energy efficient motor efficiency, which can be obtained from the table above. Average efficiency and typical list price for standard and energy efficiency motor. When we substitute the value of each parameter, the final value of kilowatt saved obtaining is 1.78. Next is energy saved. We use formula kilowatt hour saving equal to hours of operation multiply kilowatt saved. Cost of operation, basically we use 5110 hours in a year, and kilowatt saved is 1.7x. Again, when we substitute the value into the formula, we get 9095.8 kilowatt hour per year. Next, what we want to know is cost saving. Use formula total cost saving equal to kilowatt saved multiply 12 multiply monthly demand charge plus kilowatt hour saving multiply energy charge. Substitute all the value into the formula. We know that the monthly demand charge is Rm29.6 and energy charge is 33.7 cents per kilowatt hour, which is obtained from table utility rate. After solving the calculation, we know that the cost saving is Rm3697.54 per year. Sunday tariff rider equal to kilowatt saved multiply 1.6 multiply monthly demand charge, where 1.6 is total of Sunday in a year is equal to 1.6 month. Substituting the value, we get Rm84.3 for utility rebate. Next, we have to find the payback period using formula simple payback equal to list price premium minus Sunday tariff rider per total annual cost saving. List premium can be obtained from this table by referring to list price premium at 100 HP TFC. $1019 convert to RM, we get RM 4126.95. Lastly, enter all the obtained value into the formula, and we know the period payback is equal to 1.02 years. Thank you.